The object first appeared as nothing more than a faint point of light, barely distinguishable from the background stars. Early images showed no drama, no flare, no spectacle. Just a compact, sharply defined source moving steadily against the celestial backdrop. Yet even in those first observations, something about it felt unusual. Astronomers are trained to recognize patterns, and this object did not fit comfortably into any familiar category. As it entered deeper into the inner solar system, expectations were clear. Bodies following this path, exposed to increasing solar radiation, almost always begin to react. Ice warms, gases escape, dust lifts from the surface. A halo forms. A tail stretches outward. But this object did none of that. Month after month, telescope after telescope confirmed the same unsettling result. The surface remained clean and unresolved. No surrounding haze. No trace of vapor. No dust scattering sunlight into a visible coma. Instruments capable of detecting even whisper-thin clouds of gas reported silence. The object's appearance did not evolve as distance to the sun decreased. It simply remained what it had always been, a bright, star-like point, unchanged by heat that should have transformed it. This visual stillness became the baseline, a reference image burned into the databases of observatories worldwide. If something dramatic were to happen later, scientists would know exactly when the change occurred. But while the images stayed quiet, the numbers began to speak. Precise tracking revealed that the object was not following the path gravity alone predicted. Tiny deviations at first, easily dismissed if seen in isolation. But over time, those deviations accumulated. By early winter, the offset was undeniable. The object was drifting thousands of kilometers from its expected position. This was not noise. It was not observational error. It was a sustained acceleration acting on a body millions of tons in mass. The force responsible was small in everyday terms, but enormous in an astronomical context. Enough to reshape an interstellar trajectory over weeks. Enough to demand an explanation. Gravity could not account for it. Planetary encounters did not align. Radiation pressure was insufficient for an object of this size. What remained was a familiar answer with an unfamiliar twist. Non-gravitational acceleration, typically caused by outgassing. In comets, this process is well understood. Sunlight heats volatile materials beneath the surface. Gas escapes through vents, dragging dust along with it. The escaping material acts like a thruster, pushing the nucleus in the opposite direction. The physics is clear. The visual signature is unmistakable. When it happens, comets glow. They grow tails that can stretch millions of kilometers. They announce their activity loudly across the electromagnetic spectrum. But here, the math and the sky did not agree. To produce the measured acceleration, the object would need to expel billions of tons of material in a short period of time. That scale of mass loss is not subtle. It cannot hide. If it were happening, the object would be wrapped in a brilliant cloud of gas and dust, easily visible even to modest instruments. Instead, every image showed the same pristine point of light. The required force was there. The expected evidence was not. As the object passed its closest point to the sun, anticipation reached a peak. Perihelion is often the moment when dormant bodies awaken. If anything were going to change, this would be it. Observatories watched closely. Space-based telescopes gathered data without atmospheric interference. Ground-based facilities coordinated coverage across continents. Yet the result was once again silence. No coma bloomed. No jets flared. The object rounded the sun and continued outward, still compact, still quiet. Upcoming milestones offered new opportunities. As the object approached its closest distance to Earth, telescopes gained their best chance to resolve fine details. Infrared instruments searched for faint thermal signatures of gas. Spectrographs scanned for the chemical fingerprints of water, carbon monoxide, and more exotic volatiles. Polarimetric measurements probed the nature of any dust too thin to see directly. The observing campaign became global. Major facilities synchronized schedules. Data pipelines were tuned for extreme sensitivity. Detection thresholds were pushed to their limits. This was not casual curiosity. It was a coordinated effort to answer a fundamental question. Was this object behaving like a natural comet, or was something else at work? As the data arrived, the puzzle deepened. The object's brightness did not follow the gentle curve typical of comets approaching the sun. Instead, it surged dramatically, brightening far faster than established models predict. The rate of increase was extreme, well beyond the range observed in known comet populations. Such rapid brightening is usually accompanied by violent outgassing and fragmentation. Yet again, none of that was seen. Color measurements added another layer of strangeness. Near perihelion, the object shifted toward blue wavelengths. This is rare. Dust-dominated comets tend to redden as particle clouds scatter sunlight. A blue shift suggests something fundamentally different, either in composition or in how light interacts with the surface. Multiple instruments confirmed the effect. Calibration errors were ruled out. The blue color was real. Each anomaly alone might be explainable with creative modeling. Together, they formed a pattern that resisted easy dismissal. The object's trajectory aligned unusually closely with the plane of the solar system. Its speed exceeded expectations for bodies ejected from distant star systems. Reports hinted at directional features pointing sunward, not away. Its inferred composition showed ratios uncommon in known solar system materials. Water, the lifeblood of cometary activity, appeared surprisingly scarce. Statistically, coincidences happen, but the accumulation of unlikely features forces attention. At some point, probability stops being comforting. This is where the scientific debate sharpened. Some researchers urge caution, emphasizing that nature often surprises us. Unknown cometary behaviors, exotic ices, or unusual surface structures could potentially reconcile the observations. Others argued for a stricter approach. Science, they said, advances by confronting mismatches directly, not smoothing them over. The proposed method was simple. Define clear criteria. If the object releases gas at the required rate, instruments will detect it. If a coma forms above a specific brightness and size threshold, the natural explanation holds. If spectral lines appear at predicted intensities, the case is closed. But if none of these signatures emerge, then the standard model fails its own test. This is not speculation. It is falsification. By early next year, the data will be complete. Either the sky will reveal the missing mass loss, or it will not. There is no middle ground. The outcome does not threaten Earth. No collision scenarios exist. The stakes are not safety, but understanding. If the object behaves like a comet at last, it will expand our knowledge of how diverse natural bodies can be. If it does not, the implications are deeper. It would mean that something moving through our solar system does not fit within existing categories, even when measured with humanity's most powerful instruments. Moments like this are rare. They force science to pause and listen carefully, not to fear the unknown, but to acknowledge it honestly. The universe does not owe us familiarity. It only offers data. As telescopes continue to track this silent traveler, one question hangs in the balance. Are we witnessing an extreme example of natural physics, or the first clear signal that our assumptions are incomplete? The answer will not come from belief or disbelief. It will come from observation. In the end, the object itself will decide. The numbers are written. The instruments are ready. All that remains is to watch, measure, and accept what the evidence reveals, wherever it leads.